This is Calculus Homework, page 241. They want us to graph this function, sketch a graph using Graphing Calculator. So it's cube root of x plus 2. So I'm going to go and choose a new graph. So it's cube root of x plus 2. There we go. Ooh, looks like there's a vertical tangent going on right there. And if a function has a vertical tangent, will it have a derivative there? It looks like it's continuous. But the vertical tangent has me a little worried about the derivative. Okay. Now, they want to know at x equals 0, is it continuous? So right here, we know that, okay, as a sideways cube root graph, okay, we can tell from the graph it's continuous, but we do have to explain it using our definition of continuity. Step 1, remember, is first of all, okay, we want to know if this exists. So it's defined. So we just plug in. We know the cube root of 0 is 0 because 0 times 0 times 0 is 0 plus 2, and that's 2. So yes, it is, and we have the point 0, 2. So we know the coordinates of that point are 0, 2. Second step is to prove limits. Okay, this one is going to be easy. We want to know if the limit of that function as x approaches 0 exists. This is one we can just plug in. No piecewise, nothing like that. Plug in 0, and we know that's also 2. And then the third step, if you recall, is all we have to do is say, okay, that the value of the function at 0 is equal to the limit of the function as x approaches 0. All right, and when we do that, okay, we know that that's also 2. So yes, it is continuous. All right, the next thing is differentiable. I'm seeing a vertical tangent there. Let's check our derivative. That would be 1/3 x to the negative 2/3. That's 1 over 3x to the 2/3. We plug in 0 for x, and that does not exist. Okay, so therefore it is not differentiable there, and we know that because we have a vertical tangent. That was problem number 1. All right, number 2. First of all, let's sketch the graph. This is, okay, the x to the 2/3 plus 2. Another graph. Looks like a cusp, doesn't it? That does not look good for a derivative existing there at that point. All right, let's follow. Okay, it does look like it's continuous though. Let's check it out and see if it is continuous. First step, okay, does f of 0 exist? Is it defined? We have 0 to the 2/3 plus 2. That's the cube root of 0, which is 0 squared, still 0 plus 2. So yes, it does at the point 0, 2. And we can see that on the graph that it exists there. Secondly, our limit. We need to know, what about the limit of that function as x approaches 0? Once again, we can just plug right into that one because there's no piecewise, no rational expression. We can just plug that in. That's 2. That's true. Third step. Okay, is the function equal to the limit of the function as x approaches 0? That's x. And the answer is yes, they are. They're both equal to 2. So yes, it's continuous. Let's check the derivative now. That'll be 2/3 x to the negative 1/3 All right, and when we do that, we plug in a 0 here. That's going to make it not exist. Okay, therefore, it is not differentiable. At that point. That concludes page 241 of the homework. Thanks for watching.